production when something goes out. Another major benefit is the IntelliSense in IDEs. Autocomplete for VS Code and TypeScript is just awesome. You know exactly what's on an object, what arguments a function takes, and it sort of lowers that cognitive load so you don't have to remember every piece of every part of your code. And as a code base grows, that can be really, really helpful. The other way it helps is in preventing clever code mistakes. So if you've ever had a feature request or a bug fix where it's like, oh man, this would be so easy to fix if I could just have this function that used to take an array also take an object. Well, TypeScript will help you in that it will put up guardrails and make sure that you're doing all your type checks, your null checks. You're not going to try to call concat on an object that isn't an array. And one of the major benefits is that it makes everything easier to read and understand. TypeScript acts as a sort of documentation in that it defines your contracts between components, and you can it's a lot easier to understand. So I think SendGrid has hired about 8 new front-end engineers in the past year, and those engineers have been able to jump right into the code base, understand it, and make PRs that get merged into master and out into production within their first week, which is just fantastic. So, what my next slide is. Oh, but this is not a sales pitch on TypeScript. This is an exercise in reaching TypeScript nirvana, or aka just maximizing type inference. So by maximizing type inference, I mean making TypeScript do the heavy lifting for you. So you should really only have to type a variable once when you get it from the API or when you get it or when you create it. And TypeScript should be able to retain that type information the entire time you're using that variable, no matter where you're passing it, how you manipulate it. TypeScript should just be able to tell you what type it is. Cool. So some of the patterns we're going to go over for strongly typed React in TypeScript are state management. State management is probably the most important thing in a single-page web app. I mean, you get state from the API, and then as the user is clicking around on things, manipulating things, you need to keep track of that state. Then we'll talk about Redux connected components. If you're using Redux for your state, you're going to have to use Redux connectors to get that state into your component. And we'll go over higher order components, which connected components are actually a subtype of higher order components. And then I have miscellaneous, which is just a bunch of things that I wanted to get in this talk, but I didn't necessarily have a good heading for. So for the purpose of this talk, we're going to be looking at a demo app that I built. It's on github.com/mmissey/tsbase. And this app is mostly the architecture, like a boilerplate for the architecture that we use at SendGrid. It uses Redux observables, TypeScript, some other cool stuff. Anyway, the app that I built is just a simple CRUD app for getting posts from a subreddit. This one is from r/where-did-the-soda-go. If you don't know that subreddit, it's a bunch of funny captions on images from infomercials. And so it looks something like that. Cool. So let's get into strongly typed state management. So if you've used Redux, you've probably seen the Flux paradigm. And that is that components trigger actions, actions are dispatched onto the store, reducer picks that up, inside the store changes the state and produces a new state that then gets given back to the components. But in reality, it gets a little bit heavier than that. It looks more like this. You have action types that actions are using, and then those trigger side effects like or API calls, like you might have Redux thunks or sagas or Redux observables. And then those API calls come back, they trigger more actions like success, action, failure. That gets picked up by the reducer, they go into containers, and then back to the components. So let's look at a code example of strongly typed state management. Is that readable? Cool. So this is my action types file. And we have an object here that's got my actions. I've got fetch images success, fetch images failure. This is a TypeScript enum. And what that is actually sort of the key to this pattern in that it's both a JavaScript object and a type. So you can see I have a const here that I'm setting equal to the JavaScript portion of this enum. And I've got a type here, my enum, that I'm setting equal to the type part of it. It's complaining because I'm not using it here. But the type part of that. Cool. So those action types are being used in my actions function. So you can see here I've got an object called actions that has fetch images, success and failure. We're pulling in our action types here and passing it a payload for what the action is going to expect. And then down here, we are exporting actions with this actions union, which is a helper that I'll show, and the default actions as well. So both of them are called actions, which is part of how this works. So if we look at create action, which is our actions helper, I'm pulling in 2 types from Redux, action and action creators map. And then I'm extending action with payload. So this is a TypeScript generic, and it extends the regular action type that has a type of string, and then has a payload of type P, whatever gets passed in. You can skip these 2 for now. This is the main action creator function. What you see here is that we have an optional payload, and then if payload exists, we're going to return both type and payload. If not, we just return type. And here we have type definitions overloaded, so that TypeScript knows that if it just has a type, then it's an action. If it has a payload as well, then it's an action with payload. And down here is the actions union helper that's really helpful. So what this is doing essentially is saying, okay, I want the return type from each of these action creators. So if we look at the type of this actions union, you can see that we have the 3 possible actions, but not the action creator parts, but the actual action with payload. Cool. So now that we have action types and our actions typed by using our action helpers, wow, that's a lot of words. Let's look at the reducer. So this is where we get a lot of really cool type inference. So because we have our images reducer, takes an image map, which is just a map of images, and here is our actions union, which is those 3, oh man, it's cut off, our 3 actions here. So it gives us a lot of awesome type inference in that now the reducer knows that only those 3 can exist on here. If you try to type fetch image, it's like, here, it doesn't exist. It also knows exactly what the payload for each of these is. So if I do that, I get some awesome autocomplete, because it knows that subreddit's on here, images on this one, and air is on this one. So this is our reducer, and then we connect this back up to our state using the root reducer. This is a common pattern with Redux. We pull in our combine reducers function. We have our 3 different reducers, and then we're using the generic here to tell TypeScript that this should have this shape with galleries, images, and users. That way, if I do something like remove images, this starts to complain, giving this massive error message. So it knows that users has to exist here. So that is strongly typed state management. Next, we'll go into Redux connected components. So if you've used Redux before, you've probably seen connected components, and they look something like this. So we've got our map state to props function, which just pulls something off the store and returns it. We've got our map dispatch to props, which has 2 actions. They're dispatched onto the store. And then we've got our connect function, which is actually, that's the higher order component that takes both the state and the dispatch props and gives them, wraps your given component with those props. Cool, so let's look at how we can strongly type that. Is it still full screen? Great. Cool. So if we go to my with image connector, if you're new to TypeScript, you might think, okay, well actually let's look at the component first. So we've got our image route modal, and that has props, image modal props, so that's an onClose. That takes an event, it's a mouse click on a div element. And then we have our props included here when we're declaring our component class. We also have route component props because this is an image route modal, so depending on what the URL is and what params you get from React Router, this will render a specific image from the store. Then we have our with image props, which is coming from that connected store. That's all you need to see there. And we have with image. So here's the connector. We've got our regular map state to props function. If you're new to TypeScript, you might think that, oh, I can just type this as any because I don't know what own props might be, and I need to grab this ID off of here. That's cool, but it's too loose. So you can type anything here, and TypeScript won't complain. That's kind of a problem. You want to make that a little bit stricter. So the next step might be to have a generic. So we have own props as T, and then T must extend these props that we're expecting to get from React Router. That's nice, but it's not very extendable. If you want to use the React Router .location, that's not there. So that works, but it's not great. What we figured out we could do is make this type called required props, and this is equal to a prop type, or a type that comes back from React Router, which is route component props, and the URL parameters are here, ID string. You can also extend this if you have more things that you want to pass into required props. And then we use that for our map state to props here. We say T extends required props, so it must have those React Router props on it. Then we get our autocomplete here, so we know that we have ID, we know that we have location and history, all that cool stuff. Awesome. That's how we would map, how we would do the map state and the map dispatch to props, but we don't have a map dispatch to props in this particular example. Then we have this type called state props, which is using return type, which is a helper from TypeScript 2.8, I think. That'll just give us the return of whatever this function is. So here it'll say the return type is just an image. But this makes it really easily extendable because if we have like mark is true, then you can see that the state props also has a mark boolean now. So as your functions change, your state props will stay up to date, your dispatch props can stay up to date. Everything's awesome there. Then we export this with image props, and that's what we're using in the route model, so that we always know what props we're expecting to get from these connectors. Okay, so connecting our component. We're going to call the connect function, and naively you might say, oh cool, that works, that didn't complain about anything. But here, I have an example down here where if we were to import our route model and wrap it with image and with router, this is TypeScript's complaining now. And it's saying that property onClose doesn't exist on here. But we know that it exists because we just looked at it in the image route model. So the problem here is that when you don't give connect any types, it sort of types it as an any. So we still got the required props because we expected those, but we got any here. You see there's an any here. Some of these things can be really convoluted as they grow. But essentially, it doesn't know what types are supposed to exist on this. So what we found we could do is comment that out, is use the generic for this connect. And so we still take a component that has types P that extends required props, so that's the route props. And we pass it the state props, the dispatch props. We don't have any dispatch props. And then here we do this subtract. So we subtract from P, we subtract from the props with image props. The reason for that is because connect is going to also attach these with image props to it, and we don't want TypeScript to think that you need it twice. If you take that out, then it's like, hey, you're still missing your image that we're attaching. So now, TypeScript stops complaining, and it knows that onClose is supposed to be on there. If you remove this, it says, hey, you forgot onClose. Awesome. So that is our connected component. Is this still full screen? Cool. Next, we'll go into higher order components. So, higher order components. You've probably seen higher components. They look something like this. They wrap a component with additional props. So what this one is doing is it takes in a component, and the class returns this component that has a state. So we have is loading is false, and then on mount, we're checking to see if there's images in here, if there's not, and if it's not loading, then we're going to fetch that subreddit and set the loading to true. When it updates, we're going to, if we have images and it still says we're loading, we're going to set loading to false. Then we attach loading onto here. Cool. So let's look at it in code. So if we go to my with image list connector, this is going to be a lot like the previous connector too, because we still have map state to props, map dispatch to props, because this has the action on it. And we still have the same state props and dispatch props, but here we have injected props. So this is the is loading that's going to be a new prop that's given to your component that you're wrapping. So with image list props also includes that injected prop so that the list component will know that we have this is loading function, or this is loading prop as well. So the fetcher, we just extend those with image list props, and what that's doing is it's saying, hey, anything that's going to use this fetcher, it has to know that it has these props before it uses this. That way we don't have a mistake there with typing. So we're returning this class. This one has the props that get passed in, and it also has state from the injected props. We set a display name because that's best practices. I don't really actually do that very often. We have a state. that's false. And then on mount, we're doing the same thing. And update, we're doing the same like check to see if we need to be learning, and we're passing it in here. And that's as simple as it is to really type higher order components. Except down here, when we are wrapping, when we're wrapping this this component with our function, with our fetcher higher order component, I'm doing this thing where I have contains with image list props, and contains is just a helper that I made that says, hey, you can have any props you want as long as it has T. And T here is with image list props. Cool. And so we do that subtract again here, and everything should be good. I can hear the complaints already. Mark, why are you talking about higher order components? Why aren't you talking about hooks? Hooks are the new hotness. Which is true. Hooks are awesome, but they're pretty easy to type. They're pretty functional. You just give it a type when you name it, essentially. It's all good. Plus, higher order components are a little bit more complicated. They're a little bit more universal too. So hopefully that stops some complaints. Going fast. Next, we have just the miscellaneous section. So, miscellaneous. Typed Webpack. This one's just pretty quick. Why would you want to type your Webpack configs? That sounds like a mess. It's actually pretty awesome. So we import this type, which is called configuration, from Webpack, and then throughout your config, TypeScript just knows what's supposed to be there. So you type path, it's like, okay, you got a path, and then you know what you can put here, and it's a string. Same thing with like loaders and rules and everything. It type checks your Webpack config, which can be extremely helpful sometimes. You don't have to look at the Webpack documentation constantly, although I still do. But yeah, that gives you some really cool autocomplete and just type checking on your Webpack config as well. Now what we do at StronglyTyped is we have our base Webpack config that's exported like this, and then we have configs for both production and development that then import that Webpack config and extend it using object.assign. And then you noticed that the compiler was complaining a lot, and so you have to export something from this. I think that might be fixed in the new one because when I removed this, it didn't complain anymore. But if you're using an older version of TypeScript, you should make sure that you export something from your Webpack config, which is a stupid hack. Anyway, so next we have type definition files. So type definition files are those type def files that end in .d.ts. So what this allows us to do is put our types somewhere, and then they just become global throughout the project, which can be really helpful. So you don't have to import types, export types, know where everything is, have the correct path to things all the time. And that works by, in your TS config, you set your type paths, here, type roots. We have both node module / add types because that's how most of the definitely typed stuff is typed. And we have our source types, which is where my root types are, or my definition files are. We also have definition files for each of the different types of resources. Cool. So next, we have untyped dependencies. So if you are using libraries that might not have any types at all, first you should try doing something like this. Just npm install save dev types at module, because that is the definitely typed repo is like a community sponsored repo where people go to add their own type definitions for libraries that might not have them. But if that's not good enough still, you can declare a module and name it whatever the import is. I'm not actually using Storybook React in this repo, so that's why there's a squiggly. But then you can tell it, okay, when I import this and then I want to use it, this is the shape that it's going to look like. It has a story decorator, and that comes from Storybook. Yeah. So you can import and export things in here, and this is still inside of a typedef file, but because it's inside of this module declaration, it's all good. Cool. Enums. Enums are super cool. We talked about them for our action types. But you can also use, so like I said, enums are both JavaScript and TypeScript types. And that makes it really powerful because then you can import them into your JavaScript files and use them however you want. So you've got colors here. Like we could import raw and burgundy, which is a reddish burgundy color. or any of these other standard specific colors. Screamful, I don't know what that is. Cool. So imagine we had this enum of colors and we want to extend our user object and say, okay, now we want theme colors, and that's optional. It's going to be one of the colors that we're using. So we would import colors, and cool, that works, but, where'd that error go? There's an error. And this says that cannot find user's map. So what happens if you try to import or export anything from a definition file, then suddenly these don't become global anymore, and that can be really annoying. So what we found we could do, though, is, cancel that back out, in our enums, is you can declare a global namespace and put these types on there, put your enums in here, and those become global. The reason this is typed as T colors instead of colors is because it complains and says, hey, it's a circular reference, you can't do that. So it's a little bit of a pain that we have to have a different name for it, but that allows us to not have to have imports and exports in our definition files, and therefore we can just avoid importing and exporting types all over the place, which is great. Cool. Next miscellaneous item is conditional types. This one can be super cool. So I've got an analytics middleware, and this is a Redux middleware that takes in any action, extends all actions, so it's any of those 9 that were the original. So it's all the fetch images, all the fetch user, and all the fetch gallery stuff. And then we're going to track an event on there. So I have this log function where action is one of those 9 actions, and it's going to fire. It's going to say fired resource, the action, and the action type. And so here I just have those resources bound to that same function with images, users, and galleries. But how do we track those types? So I've got this conditional type here called filtered actions. And what this is doing is saying for each of the keys in B, and B here is base action, so for each of these images, users, and galleries, if the action extends B at key, so if it extends this one, or if it extends this, or if it extends galleries, then return that whole map of those 3, else return never. So what that ends up looking like is we have an incoming action here, that's fetch images, and then we filter that out, so we filter based on the type of the incoming action against the base actions, and that gives us, see if I can get that all on screen, here. So that gives us the 3 actions for images, but then for users and galleries it says never. Then, got an additional helper type here called action type, and what that's doing is it's taking filtered actions, it's returning the key of, so it's returning like just that one. What that does is it narrows it down, so instead of having those 2 nevers on there, it's just the images actions. So that allows us to do this cool thing where as the action comes in, we get the type off of here, and so this would be like image.fetch.success or something. And so split and get the first one, so that's going to be a resource, either image, users, or galleries, and then I grab a log function that is this type here, just takes that specific type, which takes like an images action or galleries or a user's action, and returns void. And then we were able to call that. So by the time it gets into this log function, it knows what type that action is, and so we don't have to type anything as any. We don't have to be confused about what type things are, and we can have stricter typing even though we're narrowing it down from a large number of actions. So in the SendGrid app, there's even more actions. It's like all of the possible actions you could have on a large application. And we're able to narrow those down, and based on what type that is, send it to a particular file where we have particular like segment IO calls that get fired off based on what the payloads are and stuff like that. Cool. And so finally, I have really long error messages, and I think don't panic. So you saw in, say, the root reducer that when there's the error message, and in SendGrid's app, there's a lot more reducers, so these error messages are pages and pages of this stuff. So the easiest way to read something like this is actually to skip all the quotes. So find the closest paragraph and start there. And I'm going to skip this big thing that's in quotes here. So property users is missing in type, skip all that. but required in type. So that helps you know that, hey, you're missing users. If you still don't understand what that, then you need to then you need to try and figure out some like context clues from the rest of what's in quotes. Or if you still can't figure it out from that bottom paragraph, go up a little bit because it's all nested. So it's going to say like, the next paragraph just says argument of type, and this is all the reducers. You skip all the quotes, is not assignable to the map because we said, hey, it's supposed to have this shape, and it doesn't. And that is how you read error messages in TypeScript. So I hope that this talk, if you're new to TypeScript, I hope that it made you realize that it's not just an annoyance. It's not just more boilerplate, more adding types, and more just dealing with type errors all the time. When we first started, it definitely took a lot. It was a steep learning curve. We did TypeScript and RxJS at the same time, and it was definitely a steep learning curve. We were behind on a few sprints at the very beginning, but by the time we were releasing MVP, we were miles ahead because this had helped our development so much. Our velocity was way faster. We weren't introducing fewer bugs, and the bugs that we were introducing were a lot easier to diagnose and fix. And if you are already using TypeScript, I hope that you learned something that you can go and implement in your code base tomorrow. If you're not using StronglyTyped state management, it's one that you should probably do. Cool. So here are some additional resources. You don't have to, these are all links, so I'll just share the doc with you guys. But there's a lot of really cool information. One in particular that I really like is Sharif's notes on TypeScript. He's got a lot of really cool stuff here. I've got extra time, so I'm just looking through some of these. Heroic Tech's guide is awesome. It's huge. It has everything you could possibly want for typing React components. Even has Redux Observable in here. I think it's got funcs and everything else. The reason I wasn't going to talk about hooks is because this is what typing hooks looks like. It's super duper simple. It's sort of TypeScript just knows because you tell it what the function is taking, and then it's just all good there. So I guess that is it. Thank you. Any questions?
What's the GitHub link for that code?
It's my username /tsbase. Yep. Any other questions?
Have you used TypeScript with any other front-end frameworks? Would you be able to compare them?
With other front-end frameworks, no. Lots of other libraries in React. So lots of reselect for selectors, Redux observables. So typing epics. Since I've got time, I can look at my epics file. I didn't want to confuse you all with RxJS. But you take an actions observable, and you tell it what sort of actions it's going to take, and then what sort of actions it's going to produce from there. That's cool. Selectors look something like this. Output selector, and then you give it what the inputs and the outputs and then the function that it's going to call. So mostly just React, though. I haven't done it with Vue or Angular. But I'm sure the Angular community's probably got a ton because everyone's using TypeScript in Angular now. Cool. Question? Yes?
You guys started redoing doing your project in TypeScript. How many do you have working on the initial groundwork of the project?
The initial scaffolding, the groundwork of the project, was a Tiger team. So that was the four of us. That was me, and Steve Kinney, and Chris Chalstrom, and Brenna. What's her last name? Masterson? Martinson? Yeah. So it was rough for that, what was it, month of Tiger team? And we had to get that all set up and then sell it to our team. Hey, this is the scaffolding we're going to use now. So there was definitely a learning curve there and a bit of a struggle. Yeah.
How important do you think it is to have other devs know that groundwork more easily?
We were pretty prescriptive about our architecture, and so what that allowed us to do was say that hey, this is what it's going to look like. So when you're really prescriptive about your architecture, what that means is that things go into particular places. So anything that has to do with adapting an API call has to go in an adapter. Anything that, and we're not passing promises around. You can't get a promise back into your component. So it has to be actions in, actions out from an epic, from RxJS, or Redux observables. So with being pretty prescriptive about that, after everybody got it, that helped us to really move quickly. And when I said earlier that it was easier to diagnose problems, with an architecture like this, you're able to say like, oh, that issue, that has got to be coming from the service layer. And so you can just dive right in there, find the bug and fix it, especially with TypeScript, because there's fewer of those like outlying bugs, like weird side effects that happen from trying to be too clever and having your function do everything. Cool. Yes?
Did you declare enums a definition file?
No. Enums was not in a definition file because we need to do imports and exports. This is just a .ts. But then I have it, in order to get it on the global namespace, I have it declared down here as well. Oh, I didn't mention this, but if you're importing files that don't have types, like images or CSS, you can declare them this way. And so that just tells TypeScript, hey, don't worry about these, they don't need their types. Any other questions? Yes?
Are you using TypeScript in your tests, and are you able to reshare your types across your app code in your tests?
We are. I'm not sure how much of the SandGrid app I can show, but I don't have any types in this demo. But we are using Cypress, and everything is typed there. Just recently I changed the build process though, because before we weren't actually checking the types, but we were typing them. And so when I turned on type checking, all the tests broke, we had to fix those, but they're good now. Yes.
My question is more about your background. So first question, so how long have you been working with TypeScript and React, and where did you come from, like from JavaScript or more strictly typed languages?
I came from JavaScript, definitely. We've been working with TypeScript for about 18 months, I guess, March of 2018. Yeah, and so no, I didn't come from strictly typed. I have a computer science degree, so I knew strictly typed languages, but I hadn't really worked with them. And I always thought that would slow me down, but in fact, it actually speeds you up. That lower cognitive load and just knowing what things are on objects, like being able to say colors dot, and then you get all these, is really cool. And you prevent bugs. Yes?
When it comes to like TS lint stuff, are you using like no...
Strict everything.
Okay.
We weren't at first, so if you don't use TypeScript now, you should know that you can have implicit any on, which means that anything that you don't type is implicitly in any type. So you can mix JavaScript and TypeScript together, and TypeScript, the compiler won't complain, which is awesome. But you can see here, I have no implicit any turned to true, which is sort of like a double negative. No implicit any. And so that makes sure that everything is typed. If you have any spots in your code where you're just saying like, hey, I'm just taking a function in, or I'm taking this object in, and you don't say what type it is, it'll yell at you and say, no, that's got an implicit in.
It's not giving you any trouble with like third-party systems?
Yes. Because if you don't have definition files for them, you can see in my package.json that all these types here, those are coming from the definitely typed library, which is that community-focused thing. But if they don't have types even there, and you don't want to spend the time to make a pull request for that, you can just do this declaration yourself. So you can say, hey, this is what this looks like, stop complaining. You can also you can still explicitly call it any, so it's sort of like an escape hatch there. You can say this is going to be any, but you try to avoid that. If you see that in the PR, you should ask why. Any other questions?
What do you consider a good reason to use any?
A good reason to use any is that you don't have time to figure out how to properly type it. Because even if you can't figure out the types, like you saw, I had this sort of, I don't know if I actually went over that, but in the with image, here I am explicitly typecasting this. This is because the Redux types, I think, has a bug, or maybe I'm just not figuring it out properly. But if I get rid of this, then suddenly TypeScript complains and says, whoa, 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 and gives me this crazy error message that I don't understand. Type null extends PK, validator PK, blah, 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 blah. And all I wanted this thing to know is that, hey, this has required props. Stop complaining. And so what that allows us to do is in the route modal, if I were to get rid of some of these props, like say we no longer have with image props, and so now this doesn't know about this prop called image, and didn't complain down here. It's supposed to complain. I guess it's not as strongly typed as I thought it was. If I get rid of this one, that's just the onclose. This one will probably do it, because React Router complains about everything. So it doesn't have location. Oh man, look, it's complaining. It's saying props is missing on closing image. Uh-oh. It's supposed to say it's missing history, location, and match. But I guess it's not typed as properly as I thought.
Does it matter the order of your props that you?
So it can matter for the order of how you use your connectors. So what we were doing before, and I didn't realize this was causing that problem, is I showed you the initial connect with no types on it at all, and how that just types as an any. So it's not complaining here. If I change the order here, it's not complaining here either. What we found was because it was, it's because I have those required props. We didn't have those required props before either. But React Router would start complaining and say, hey, this component you gave me back is an any. It doesn't have the required props on it. It doesn't have the router props. And so that was very confusing for a while. And we came up with a couple different ways to try to do it. Like I would make the connector generic, and then we would just like explicitly call the generic right here and tell it what types it had. That was not as strictly typed as I thought it was. So we figured out a better way to do that. Cool. Any other questions? Yes, sir.
You mentioned it was a pre-seed version for after you had experience that. Is there anything that would have made it simpler if you know?
All of those additional resources. So these are things that we found, these are links that I found after the fact. And because TypeScript has become more popular in the past year and a half, there's been a lot better articles and a lot more cool stuff to look at. Ultimate patterns, component typing patterns, I think this one's pretty good too. This internet loads. Yeah, those additional resources. So I will share these slides. Oh, actually the slides are in the repo as well, under docs presentation. As a PDF too, and the markdown file. Cool. Any other questions?
Are you going to share the slides somewhere like on Slack or?
Yeah, I can do that. And like I just said, in docs, presentation, and this internet is slow. I've got the markdown file, I've got the slides as a PDF here, all the images. Probably has my speaker notes, so you know my jokes were actually pre-thought out. And it's very slow. But yeah, it's all here. And I will share this link in like the closed Slack because I don't want people messaging me. So I'll share that in Slack as well. Anything else? All right, thanks for coming.